For our purposes, I will be demonstrating a 19-inch 4U rack-mounted model 15-1000-125A-1 with single battery monitor for 125 volt DC systems. Presentation of the battery monitor display. As you look at the front of the battery monitor, you can see two windows. The upper window displays voltage, time delay, and phase selection of the AC chargers. The lower window displays the setup menu. You can see there is an auto LED indicator on the top left and an alarm indicator LED on the top right. There is a reset button underneath the alarm LED to reset alarms, a limit button to transfer between functional displays and also identify limits for specific values being displayed and monitored. A scan manual button is in the bottom center, which allows you to scan between various displays in the upper window. There are up-down buttons to the left of the setup menu to allow you to adjust limit set points to the end customer specific needs. Finally, a pulse on LED that is on when you're making use of the pulsar and the handheld detector to locate a ground. As I stated, the manual scan push button allows an individual to view the overall battery voltage of 125 volts DC and then scan through the other various displays. By depressing, releasing the manual scan button, one is able to view the various available indications, including the positive side of the battery voltage, which is half the battery voltage on the positive and negative side, plus or minus 0.2 volts DC. The next view is a fault voltage indication, which is currently 0, because there is no ground fault. If I did have a ground fault, there would be a voltage shown, and you would see a proportional change in the positive or negative voltages depending on the level of the ground fault. You will see that later when a ground is simulated. Next, you can see what ripple voltage is if you are monitoring the impedance of the battery, and then ripple current. This is to allow one to identify whether or not there is some degradation going on with the battery terminal connections, or maybe some other issue driving one to check the battery. Next is a time delay that is available to preclude spurious alarms. It is set at 2 seconds for right now and can go up to 60 seconds. So those are the basic displays. Next, by depressing and maintaining the limit button to press, we switch the display screen to view the various limit point settings for the battery monitor. For example, high-low voltage set points, plus minus ground fault setting, ripple voltage, ripple current, time delay, AC power supplied either single or three-phase, pulse generator on or off for ground detection, buzzer on or off, which is an audible alarm that is internal to the battery monitor, or the relay outputs latch on-off. If any of these need to be adjusted, it is done with the up or down button on the left lower section of the battery monitor. Now that you know what these settings are, let me demonstrate what happens as the voltage is increased to the high voltage alarm by increasing the voltage to 145 volts DC. You observe that battery voltage is increasing on the meter indication. When I reach 145 volts DC, an alarm LED on the top right area of the battery monitor will activate, and subsequently, a corresponding high voltage alarm LED will illuminate on alarm outputs to the left of the meter for the rack-mounted battery monitor. At the same time, if I have the sonic alarm enabled, it will provide an audible alarm which can be turned on or off during the initial setup for the monitor. It is a little different on the portable unit, as there is a toggle switch to turn off the audible alarm. If this was hooked up to serial communications using DNP 3.0 or Modbus, you would be able to send output alarms and voltage to the SCADA system. As an alternative, output options include current source outputs of 0 to 1 milliamps or 4 to 20 milliamps by direct connection. As the voltage is again decreased below the 142 volt DC set point, the LED alarm on the meter will go off, and then the other high voltage alarm LED on the monitor case will go off. The same will occur as I decrease the battery voltage to the low voltage alarm of 105 volts DC. An alarm LED on the top right area of the battery monitor will activate, and subsequently a corresponding low voltage alarm LED will illuminate on alarm outputs to the left of the meter for the rack-mounted battery monitor.